Time for my ground source heat pump lecture. In Quebec, where this house is, the electricity comes from hydropower mostly, and they don't have a lot of natural gas. It's not quite the same as we have here. So one of the better options for heating system is a ground source heat pump. In the Ecoterra house, they actually have they use the open loop system like in the top right. So they actually bring well water, use well water, which is quite nice because then you've got a pretty constant temperature. Either of the other two, the temperature will vary as the year goes on because you will actually cool the ground down, so that by the time February comes around, if your field is not quite big enough, it can actually be pretty hard to get enough heat up to keep the house warm.
So when you say used well water, that's not grey water, you say?
No, they just they pump water out of a well,
yeah,
and then they inject it back in another well, so that the heat then gets put in somewhere else, and then as the aquifer flows, you don't pick up heat from the ground and so on. But you don't typically have, like, the wells need to be far enough apart that you don't have cross-contamination.
mm-hmm.
Because if you take enough heat out, you could freeze the water in the ground.
Mm-hmm.
If you had some way for that heat to get back into the well that you're supposed to have it. But that's not typically terribly difficult. In Saskatchewan and Alberta, a lot of our electricity comes from coal, which means, and our normal heating option is natural gas. There's a lot of the world that is switching to natural gas because it's a clean fuel. So, just to kind of put some context in that. So we kind of, our back of the envelope calculations show that if you take the electricity that we get from coal, take the coal, turn it into electricity at a rate of about 30% or so efficient, and then ship it to a house, and then turn it back into heat at a rate of 300%, it's basically approximately the equivalent of burning that coal directly in the house. So greenhouse gas-wise, that's kind of what you're looking at. Whereas if you take natural gas, which is a cleaner fuel than coal to start with, and burn it in a 95% efficient furnace in the house, your greenhouse gas impact is going to be less. So first order of magnitude calculation, you're actually better off greenhouse gas-wise with a high efficiency furnace.
So an issue that I see, it sort of irks me, but I don't know, maybe you have some ideas on it. So one of your alternatives is to reduce your loads,
Mm-hmm.
which is what they think they've done here, right?
Mm-hmm.
They figure they bring the load down so much, but then they use the 30% coal to provide a significant portion of their heat.
Mm-hmm.
Even if they meet net zero by putting back as much PV as they use, I don't think there's any getting around that they're burning coal to heat this house, and they're doing it at 30% efficiency.
Yeah.
So for a house like this, I'm wondering, even if you got a 1.5 per COP on a ground source heat pump, would it not be better than resistive baseboard heaters?
Probably on a greenhouse gas basis, that may be true. But then you have to start looking at cost and system complexity. There's not much that's simpler than a resistive heater.
Yeah, right.
Like that's
and cheaper, right?
And cheap as well. Yeah. So if you take that money that you would be putting into your ground source heat pump at $35,000, which is not atypical, and put that into the envelope instead, that's a lot of insulation. And the reductions in energy energy that you use. I suspect, I haven't done the carbon analysis on that one, but the dollars analysis, you would definitely be ahead. And probably comfort as well, because you have pretty good on-road. You know, it's like any engineering decision. There's always trade-offs. So the University of Concordia and Hydro-Quebec both had a lot of monitoring in this house, and as a result, we didn't put quite as much in. And it's almost embarrassing the amount of monitoring that's on this house. There's still some things we can't answer. There's still some things that we just don't know. We don't know what's going on. We know from analyzing data that there's a 500 watt load showed up in June or July last summer, and then disappeared on December 30th at about noon. We don't know what it was. We can't find it, and I guess we probably won't now because it's gone. So it's just it can be difficult to measure the right things, because you have to kind of know what they're going to be before you can measure them, and sometimes you just don't know. One of the things that happened in this house is the owners put a garage heater in. There was no heat in the garage, so they bought a garage heater, electric garage heater, and put it in, and we didn't know about that. So that through our first few months of monitoring, like it just, you know, it was just a huge draw that we weren't anticipating. Another frustration is that Environment Canada, the nearest Environment Canada station, is not one of their top priority ones, so there's a whole bunch of holes in the data. And I hesitate to put this last bullet in, but the putting the garage heater in is one of the the indications that the homeowners are not really invested in making sure that their energy use was as low as possible. Now that's okay for this particular project. It's nice to have some places where it's just normal. I mean, people just go in and treat the house as a normal house, and what's the difference? One of the ones we'll look at here in a bit, that wasn't the case, and it performed really well. But how would that house have performed if it was just something normal? Didn't really understand all the implications of turning on a light switch. The other project in Montreal area is a triplex. It also has a ground source heat pump. Similar argument to what we were just talking about. It makes sense there. It has a couple of different solar collectors on it. It's obviously got a fairly large PV array, and then the solar thermal for hot water heat as well. They are doing rainwater collection on this house. Almost all of the houses, or large, quite a few of them, included some sort of a grey water recovery or rainwater collection or something like that. And almost all of them couldn't get permits to legally connect, so they aren't there anymore, which is unfortunate, but that's just where we're at right now in our regulations. So for this one, we decided to monitor all three units, monitor and log all three units as one. So this is a place where the occupancy would be 12 people at 50%, or something like that. We would adjust the occupancy up to account for the fact that there's actually 3 houses here. This is one in the Ottawa area. One of the cool things I like about this house, you're looking at the north side of it here. So you look at this house and it doesn't look any different from anything else that this builder would do. It's a standard house from the front. From the back, however,